Hi Pre-Calc, welcome back. We're going to be looking at a couple more ways to find limits algebraically today. Force a pause on your screen, you know what to do from here. So you don't need to write anything yet, but just as a reminder, when we're finding limits algebraically, in other words, that's when we give you the function as an equation, like f of x equals something, and you find the limit as x approaches a number c, then the first thing we do is we plug c into that equation, right? If we get a value, then we're good. Or if we get a number other than 0 over 0, then it's d and e, and we're good. However, if we get what, we have to do what? If we get 0 over 0, we need to do more, right? Do some more work, some more algebra work, typically, all right? Now, next year, when you're working these on the AP exam, you've got to show that you do indeed get 0, 0 initially to justify that step of doing more work, okay? Also, when I grade these on the AP exam, something that gets students into trouble a lot is using equal signs everywhere and then dropping that limit part. So what I recommend when you're doing these is just go ahead and do arrows between each and every step. That way you don't have to rewrite the limit as x approaches whatever every single time, okay? So you either need to rewrite it every time, and you can use equal signs then, or you can just draw arrows because that's what we're looking for, an expression that is going to be equivalent to our original expression for the majority of all x's. So we can do arrows for what we're approaching. All right, so we did quite a few do more strategies with the last lesson. We did factor and cancel as our main one. There's also the signum function, or the broken railroad tracks, where you draw it out and you can see that the limit is either going to be -1, 1, or d and e for those. And we're going to go over two more kind of algebra techniques today. Okay, so first pause on your screen, go ahead and copy what I have. All right, so if we have this limit, the first thing we want to do is put 0 in for all our x's and see what we get. So in the numerator, we get square root of 7 minus square root of 7, which is 0, and in the denominator, we certainly get 0. So what I want you to do is just show that you have tested that, and in parentheses, put 0 over 0. So that just tells your teacher, tells the readers on the AP exam, we've tested it, okay? So we are allowed to do more. So our do more here is going to be to multiply numerator and denominator by the conjugate. So take a look at where you've got all your square roots. Where do you have them, numerator or denominator? Numerator. So what I'm going to do is take the conjugate of my numerator. Remember, that just means switch the sign in between the two square roots. So I'm going to go square root of 7 minus x plus square root of 7. Just change the sign. Now, what I do to the numerator, I've got to do to the denominator, right? Because this is basically a fancy way of multiplying by 1, which doesn't change anything. Okay, now that we've got this multiplied, what we're going to do is go ahead and distribute the numerator. So I am going to take my original numerator and basically FOIL it or distribute it to all of this. Okay. Then in the denominator, I'm going to leave it in factored form. Okay, so let's go ahead and draw our arrow. That's going to allow me to drop off this limit notation. And let's go ahead and distribute. So when I do square root of 7 minus x times itself, I'm just going to get 7 minus x, right? And that's the whole point of multiplying by the conjugate. Now when I take this term and multiply it to this term, I get the exact opposite of when I take this times this, right? Those inner terms are going to cancel. So I can get rid of them. I don't need to worry about them. Now, this negative square root of 7 times positive square root of 7 is going to give me just negative 7, right? Basically, this is a difference of perfect squares. So I can rewrite, this is essentially the factored form of this numerator, all right? So now for the denominator, let's just go ahead and leave it as x times all of that. Let's not worry about distributing it. You'll see why here in a moment. Okay, so numerator, yes, distribute because you're going to get that beautiful cancellation. Denominator, leave it in factored form. Okay, in this case, because your numerator had all the square roots in it. All right, now take a look at your numerator. Combine like terms. What happens? 7 minus 7 is 0, right? So let's clean this up. We've got negative x all over x times the quantity square root of 7 minus x plus square root of 7. And now what I can do is take a look at this nice cancellation, because x divided by x is 1, so those go away. So cleaning this up even a bit more, I've got -1, don't lose that placeholder in the numerator, of the square root of 7 minus x plus square root of 7, right? So now, finally, let's try plugging in 0 for x. So I've got -1 in the numerator. I got square root of 7 minus 0, which is going to be square root of 7, plus square root of 7. So final answer, -1 over, I've got square root of 7 plus square root of 7, so that's 2 square roots of 7, and you don't need to worry about that square root in the denominator. You can leave it like that. All right. Force a pause on the screen. Go ahead and copy this example. All right, so I want you to try this one. I'm going to get you started. Take a look at where you've got your square roots, numerator or denominator? Denominator. So this is looking like another rationalizing one to me, but first we've got to make sure that we're even allowed to do more, right? So let's plug in -1 for x. So in the numerator, I get 0. In the denominator, I get square root of 4 minus 2, which is also 0. So yes, I do indeed get 0 over 0 again. Just put that in parentheses. Let your teacher know, yes, I've tested it. Okay, I am allowed to do more. All right, so we've got the square roots in the denominator. So start there and take the conjugate. So square root of x plus 5 plus 2. And then what you do to the bottom, you've got to do to the top. Okay, so this time, would you distribute your numerators through or your denominators? This time distribute your denominators. You should get good cancellation. And then keep your numerator in factored form. All right, force a pause on the screen. Go ahead and hit continue when you're ready to check your answer. All right, so when you distribute your denominators, you should get x plus 5 minus 4. Keep your numerators in factored form. Again, the reason for that is you'll end up with a factor of x plus 1 in both the numerator and denominator, so those go away. And then this is all you're left with, essentially, right? So now you can plug in -1 for x, and you'll end up getting square root of 4 plus 2, or 2 plus 2, which is 4. Notice again, I'm using arrows in each and every step so as to not make any kind of linkage errors. First pause on the screen, can you go ahead and copy this next example? All right, so for this, we've got like fractions inside fractions, right? So maybe not surprisingly, our technique here is going to be to get a common denominator. Now, once again, we've got to show that we're allowed to do more. So if I plug in 0, here I get -1/8 plus 1/8, so the numerator is certainly 0. And then when I plug 0 into the bottom, that's absolutely 0 as well. Okay, so we do want to do more here. So the do more that we are going to do is, again, get a common denominator. What I would encourage you to do first is just focus on this stuff and ignore this denominator of x. So what I'm going to do is just kind of hide that main denominator here. Or we'll come back to it, but let's focus on these two fractions first and get a common denominator with those first. All right, so you've got a denominator of x minus 8 and a denominator of 8. Those do not have anything in common, so you will need both factors in your common denominator, okay? So this denominator is missing a factor of 8, so I'm going to multiply the denominator by 8, and what I do to the denominator, I need to do to the numerator. Okay, and then that second fraction is missing the denominator of x minus 8. And again, what I do to the denominator, I've got to do to the numerator. All right, so let's work with this. My two fractions now have a common denominator of 8 times x minus 8, which means I'm now allowed to add my numerators straight across. So I've got a numerator of 8 times 1 here, which is 8, and then plus, this is a 1, so if I distribute that 1, it doesn't change anything, I just get x minus 8. Right there, right? Okay, now let's come back and bring this guy back into the scenario. Okay, so remember that this is still all over x. Okay, so working here, notice with this numerator with the orange and the red, you've got an 8 and a minus 8. Well, 8 minus 8 is 0, so those go away. So now, let's clean it up. This becomes just x in the numerator, all over 8 times x minus 8, right? And here I want to divide by x, which remember is x over 1. Well, dividing by x over 1 is the same as multiplying by its reciprocal, 1 over x. Well, how nice. Now those cancel, right? And let's keep doing arrows here. So now this simplifies to 1 over 8 times the quantity x minus 8. So now let's try plugging in 0 for x. So numerator is 1, denominator is 8 times 0 minus 8, which is 1 over negative 64 as our final answer. Force a pause on the screen. You go ahead and copy this one for me. All right, I'm going to get you started again. So again, we've got fractions within fractions. So let's ignore the denominator for now and just work with the 1/3 minus 1 over x. Notice you've got a denominator of 3 and a denominator of x. Those do not have any common factors. So you will need to, your common denominator is going to be 3 times x. So, whoops, that first fraction is missing a denominator of x. What I multiply to the denominator, I also need to do to the numerator. Your second fraction, the denominator is missing a factor of 3. And again, what I multiply to the denominator, I need to multiply to the numerator. So I'll let you take it from there. Continue when you're ready to check your answer. All right, so after multiplying, we get a common denominator of 3x here. That allows us to subtract straight across and get x minus 3. And then, again, how convenient, I also want to divide by x minus 3. So those factors are going to go away. And that leaves me with the expression 1 over 3x. Plugging in 3 for x, I do get 1 over 3 times 3. Again, hopefully you did check as well. You do get 0 over 0 initially, which allows me to do all this, do more. Force a pause on the screen. You don't need to write anything down unless you want, but we've got several cases where we get 0 over 0 for all 4 of these, and I want you to kind of think, just in your head, what would be the strategy for each of these 4. Hit continue when you think you've got them all. All right, we're back. So for this first one, I would factor out an x in the numerator and denominator, and then you can cancel. So factor cancel for the first one. The second one, I would go ahead and graph it because that is the signum function shifted to the left 3. So when you graph it, you get something like that, and you can see that the limit does not exist at x equals negative 3 because we've got this jump, right? The left and the right limit are different. They both exist, but they're not the same. For this next one, we should rationalize. And for that last one, we want to get a common denominator. All right, you all go ahead and summarize in a sentence, and I will see you all next time.